I'll start the lesson, and then yeah, feel free to please jump in because I love it when it's interactive. Okay, good morning all. We're going to be doing basic chemistry. I'm talking about like 1970s chemistry, but it's relevant today, and it's relevant to grade 10s, grade 11s, and grade 12s. And I see that even the grade 12s are a bit lacking in their basic chemistry. Now, in the old days, I'm talking about in the 70s onwards, up till about the 2013 when CAPS started, chemistry basically consists of learning about 200 chemical reactions. Like an acid plus a base forms salt and water. An acid plus a metal forms hydrogen gas and a salt. An acid plus a carbonate forms carbon dioxide, water, and a salt. And so there were, a metal and an oxygen forms a metal oxide. A non-metal and an oxygen forms a non-metal oxide. So we had these couple of hundred of reactions that the kids basically learned. And they did terribly in chemistry. That was paper 2. And so they changed the syllabus for CAPS and they made it a bit more fancy. But we can't neglect, I mean, if you come away from school and you can't speak chemicalese and you're bad at basic chemistry, although you may come through, you may even come through with an A, but it still doesn't nullify the fact that people must know basic chemistry. You must know basic chemistry. Okay, so today we're going to be doing some basic chemistry. And we're going to be dealing with the fact, what is it that causes atoms to combine? Why do atoms join together? Now, if atoms didn't join together, they'd be like sand of the seashore. Everything would just fall apart. So what is it? What is it in atoms that causes them to join together? Does anybody know the answer? Anyone? Know why
No.
atoms? Okay, anyone know the answer why atoms join together? Unlike humans that have got many desires, we got all kinds of drives, we got ambition, we got hunger, we got this, we got that, we got various drives. Atoms have only got basically one main drive. Atoms either want to lose electrons or atoms want to gain electrons. And the whole periodic table is about atoms who, to varying degrees, want to lose and gain electrons. So obviously, it's very important that we know something about atoms losing and gaining electrons. So we say that when an atom loses an electron, it's oxidized. Okay, I'll just write that word on the board. O-I-L. Oxidation is the loss of electrons. O-I-L, loss of electrons. Now there's another, this is called a mnemonic. We could also say that oxidation is an increase in oxidation number. O, increase, and it's also a loss of electrons. So what be the strange thing called an oxidation number? Now in our day, we studied oxidation numbers. Matsadiso, do you know what an oxidation number is?
I don't remember.
Have you ever heard of it? Just as a matter of interest, have you ever heard of an oxidation number?
I think so. We learned.
Okay. So it's fairly uncommon. So let's explain what an oxidation number is. Okay. Let's perhaps go to, where should I go? Maybe to the periodic table. Okay, there's a periodic table, but I must present. Okay, sorry. Let's go back. I must start presenting. present in my entire screen, allow. Okay, let's have a look at the periodic table and the strange thing called oxidation numbers. I hope that all of you can see this periodic table here. So basically, atoms on the left in group 1 want to lose 1 electron. So we actually say that these atoms have got an oxidation number of +1. +1. So it's like their valency, but it's a plus. These have got an oxidation number of 2 because they want to lose 2 electrons. Now, these guys on the right here, they want to gain 1 electron. And if they gain an electron, they become -1. So we say that this group 7 here has got an oxidation number of -1. These guys here have got an oxidation number of -2. Okay, let me just write it here. Let's put a text table here. So oxygen has got a oxidation number of -2. These guys here have got an oxidation number of +2 because they want to lose. Hey, +2. Come back to me. +2. Okay. Then we ignore all these in the middle. We call those the transition elements. Skip it right across them. Ignore them for matric and for grade 10 and 11. We don't normally do much with them. Then these have got an oxidation number of +1, +2. So when they've lost 1 electron or lost 2 electrons, they become +2. When these have gained 1 electron, they become -1. This becomes -2. Now, these guys here, they kind of can lose 3 electrons or gain 1, 2, 3, 4, 5 electrons. So they've got an oxidation number of possibly +3 or -5. Carbon could be +4 or -4. Nitrogen could be +5 or -3. So these guys are a little ambivalent about their oxidation numbers. Okay, so I'm actually giving you the rules of calculating a substance's oxidation number, and it's going to tell you which elements lose electrons and which ones gain them. Okay, let me just go back to the rules for oxidation numbers. I've got it here on this page here. Okay, so here's the rules for oxidation numbers. Rule number 1, the oxidation number of an element in its free or uncombined state is 0. For example, aluminium solid or zinc solid, look, it's got no ions, so its oxidation number is going to be 0. Here, all of these, just elements by themselves, their oxidation number is 0. Don't bother to write it down, just try and remember it. Okay, rule number 2, the oxidation number of a monatomic ion, for example, sodium, is the same as the charge on the ion. Okay, sodium's in group 1. When it's lost 1 electron, its oxidation number is +1. Rule number 3, or sulfur ion, it's -2, so therefore its oxidation number would be -2. If it's 2-, its oxidation number is -2 or 2-. Rule number 3, the sum of all oxidation numbers in a neutral compound is 0. The sum of all oxidation numbers in a polyatomic many-atom ion is equal to the charge on the ion. This rule often allows chemists to calculate the oxidation number of an atom that may have multiple oxidation states. Okay, if you get something like, unfortunately I can't write on this, like SO4 2-, then the 2- will tell you the oxidation number is -2. So it's the same rule as for these ions, but it could be a polyatomic ion. Rule number 4, the oxidation numbers of the alkali metals is +1. We already said that. Group 1, +1. The oxidation number of oxygen in a compound is -2. We already said group 6, -2. We already have discussed that. Rule number 6, the oxidation state of hydrogen is in a compound is usually +1. Why? Because it's in group 1. And rule number 7, the oxidation number of the halogens, chlorine, bromine, and iodine, and fluorine, remember they're in group 7, so they've got -1. We already showed that from the periodic table. And then oil, oxidation is an increase in oxidation number or loss of electrons. Okay, so for example, have a look here. Zinc goes from being a solid, rule number 1, oxidation number of 0, and it goes to form zinc 2+. So it goes from an oxidation number of 0 to an oxidation number of +2. If it increases its oxidation number, it's been oxidized. Oxidation is an increase in oxidation number. It says here, notice that the zinc metal, the reactant, has an oxidation number of 0 from this rule. And the zinc cation there has an oxidation number of +2 from rule number 2. In general, you can say that a substance is oxidized when there is an increase in the oxidation number. As I say, I can't draw on that, but there you go. There are the rules. Okay, I just want to go back to here. Let's just see if anyone else has joined us. Oh, great. Yay, we got the class is joining us. And they're busy setting stuff up. And I don't see the class there, and they haven't turned on their microphone. So maybe they're still arriving. But something's happening. Great stuff. Okay, for the rest of you, I just want to ask you, do those rules make some sort of sense to you? Easy enough? Easy enough? So while we're waiting for the class to come in, let's just go to the grade 10 textbook. Okay. Okay, so here in the textbook, they've got different types of reactions. Hydrogen displacement reaction. This is on page 230 of this grade 10 study and master. Metal displacement. Halogen displacement. And we could use these examples as which ones are oxidized and which ones are reduced. Okay, so do you see as zinc combines with hydrochloric acid to form zinc chloride and hydrogen gas? And here we could ask the question, which of these are oxidized and which of these are reduced? So do you guys want to just give this a go? Just write out that reaction and just see if you can write the oxidation numbers of all of these guys and see which of those is oxidized and which is reduced. Zinc plus 2 HCl. I'm just going to write it on the board. Zinc chloride and hydrogen gas. And then there's a second one, magnesium plus hydrochloric acid. Okay, let's go back to Google Meet. Still no people. Okay, any of you brave enough to give me an answer to see if you know which in this reaction, could you write the oxidation numbers underneath these?
Sir, you're still in present mode.
I'm still in the?
Present mode.
Okay, so let's just stop presenting. So let's just stop presenting. Can you see the board now?
Yeah.
Okay, great. I'm glad, Anise, that you're here, that you're prepared to speak up, and anyone else who's prepared to give it a go. So now you've got those rules, and I didn't even give you time to write them down. But here's the rule number one. If the element is by itself, it's got an if it's just an element by itself, what's the oxidation number of the element? Anyone remember the answer? And
One.
Rule number one, if it's by itself, it is naught. Okay. It's neutral. It's neither lost nor gained electrons at this stage. Okay, now let's go to this. Hydrogen is in group 1. So it's got an oxidation number of, anyone know?
2.
Group 1, 1.
1.
And chlorine is in group 7, the second last group. It's got an oxidation number of -1. So if you go to your periodic table, that's group 1. When it's combined with something, then it's going to be, if it's group 1, it's +1. If it's the second last group, chlorine, fluorine, bromine, then it's -1. Okay, now let's go to here. Now here's zinc chloride. First thing to notice, hydrogen is sitting by itself. Does anyone know again, what is an element by itself's oxidation number? By itself, it's got an oxidation number. It is 0. Because it's neutral. And now chlorine is still in group 7. It hasn't changed. So chlorine is still got an oxidation number of -1. I see those rules are a little bit incomplete, but there's 2 of them. So what do you think the zinc's is to balance it out? That's the only difficult one here. What is zinc's number? So there's two minuses because there's 2 chlorine. So zinc is +2. Do you see that? So that's by itself, so it's 0. That's by itself, so it's 0. That's in group 7, so it's -1. There's one of them attached to it, and that's in group 1, so that's +1. That's easy to work out. Chlorine is always -1 when it's combined with something. So what is the zinc? Well, there's 2 -1s, so that must be +2, so that together +2 -2 equals 0 altogether. So now we ask ourselves, was the zinc oxidized or reduced? And now we say, did its number increase? And the answer is it went from 0 to +2. Therefore, oxidation is an increase in oxidation number. So the zinc was oxidized because its oxidation number went from 0 to +2. Now, here's my question for you. Again, you got to be brave if you don't mind. Let's be silly for science. Which of these was reduced? Which one's oxidation number decreased? Which of those changed? Look at the chlorine. It starts at -1, it ends at -1. But look at the hydrogen. It starts at +1 and it becomes 0. So now its oxidation number became less. went from +1 to 0. So if an increase is oxidation, then a decrease is reduction. So H was reduced. Does that make sense? How's that? Beginning to make a little bit of sense now?
Kind of.
So let's do another one. Okay. Now you're getting the idea. Magnesium plus 2HCl goes to form magnesium chloride plus hydrogen. So which one was oxidized and which one here is reduced? So let's apply rule number 1. Any element by itself has an oxidation number of? Anyone brave enough? Magnesium by itself? 0. Okay. As there, H is in group 1, so it's +1. It's balanced by -1. That's in group 1. Now let's have a look here. The chlorine's still in group 7, so it's still going to be -1. That hasn't changed. But look at the magnesium. There's 2 -1s. This whole molecule is neutral. So to balance it out, magnesium must be +2. There's actually -1 times 2 of them. So magnesium has lost 2 electrons to the 2 chlorines. The 2 chlorines have become minus. And so now magnesium has changed from 0 to +2. What do we say when it increases? Oxidation is an increase in oxidation number. So which one has been oxidized here?
Magnesium.
Fantastic. Mg oxidized. And then we've got to look for which one was reduced, which one's oxidation number changed. Was it the chlorine or was it the hydrogen?
Hydrogen.
Hydrogen. So the hydrogen was reduced, and you can actually maybe see where the name reduction comes from. It's a reduction in the oxidation number. That's possibly why they call it reduction. So the hydrogen was reduced. Hydrogen reduced. It takes a bit of playing around and getting used to it, but I hope it's beginning to see how these would look if they were all ionic. I know H and Cl are covalently bonded, but we pretend that they're ionic. So H, if it lost its electron to chlorine, becomes +1. The chlorine becomes -1. If the magnesium, which is like it's in group 2, I'm not sure if it is in group 2, loses 2 electrons, it becomes +2. And the chlorine becomes -1 each because they're in group 7. And so looking at magnesium chloride, it is actually ionic. And that's how the magnesium is positively charged, the chlorine ion negatively charged. Okay. And I'm going to do a few more of these, but there's something else I want to talk about. Now, Matsadiso has seen this, but Anise and Michaela have not seen this, and I want to show them this. Okay. So this is going to not be new for Matsadiso, but it's going to be new for some of the others. You see, when you get to matric, and even in grade 11, you're going to be given a data sheet, your BFF, that looks like this, and you're going to be given a table of elements that have got their ions. And I don't think any of you grade 10s or 11s have ever seen this table before. But here we see them. Like here's group 1, lithium metal goes to form lithium ions, potassium metal, potassium ions, and so on. Sodium goes to form a sodium ion. So they give you this table, but so here are all the positive ions at the top, and then at the bottom are all the negative ions. You tend to have all the negative non-metals like fluorine ion, minus, cobalt, and so on. There's a lot of the more negative, there's chlorine and so on, negative ions, bromine. Okay. Now, I know I'm teaching you something new, but this is what I want to tell you. And this is my own way of teaching it. I look at the metals, the things on the left of the periodic table or the top of this, and I look at them as these are the guys. Okay, those are the guys. These at the bottom here, these are the gals. Okay, these are the girls, the non-metals. So what do we have here in this table? We have the sexiest guys at the top. Less and less sexy till we get the most average guy who sits in the middle. He's got a score on the sexiness scale, hydrogen, of 0. And then we get the hottest girls at the bottom, and that's fluorine. Okay, so here we go from the hottest girls to the less, to their 0 hot. Well, it's not that they're not hot, they're just average. Okay. So here, so just bear with me. This is just a way of remembering it. This is a table of the hottest non-metals, metals on the top, and the hottest non-metals at the bottom, and then they all become more average towards the middle. So now here's the question. Why does zinc kick out? Now let's see if we can find zinc on this table. Why does zinc kick out hydrogen out of this little comfy relationship? Okay, here is zinc. There.
You're not present.
Can you see it or not?
You're not presenting.
Oh, my word. Sorry. My apologies. My apologies. Maybe so. Okay, present now. And let's just go back to this. Okay, sorry, guys. Here is your best BFF. May take a while. And here is a standard reduction potential table that you're going to have to become familiar with in grade 10, 11, and 12. So at the top here are your cations. The bottom here are your anions or your non-metal ions. Here are the sexiest metals at the top, and here are the sexiest non-metals at the bottom. So we say Li or Liam is the most sexy guy around. Here we say Megan Fox, F, is the sexiest gal around. Okay, this is just a way of remembering it. Now just have a look at zinc. Do you see where zinc sits on the sexiness chart? There. And compare it with hydrogen, who's here, right? You got two guys. They both competing for chlorine, which sits there. So she's quite sexy. She's nearly at the top of the girl sexy table. Now, of the two, hydrogen and zinc, who do you think chlorine would prefer to go out with? Zinc or very Mr. Average hydrogen? Look, she's got a choice. Who would she go for? There's no loyalty. She was going out with hydrogen. Who would she choose to prefer to go out with? The person who's highest on the sexy table. So that is why zinc kicks out hydrogen and chlorine and runs off with chlorine. Or chlorine kicks out hydrogen and runs off with zinc. That's probably more what happens. So just go back and have a look at this. Okay, just have a look. I hope you can see my board. Does that tell you why zinc is able to kick hydrogen out? Because zinc is higher. So actually chlorine was dating hydrogen, but zinc is far more attractive. So chlorine kicks hydrogen to the curve. There goes hydrogen. And chlorine runs off with zinc. Okay, so that is how chemistry actually works on the element level. Now have a look at this. There's magnesium, comes along. Hydrogen and chlorine are in a relationship. No relationship in the chemistry world is forever. Okay, let's go to the sexy table and see where magnesium sits on that table. Is it above hydrogen or not? Okay, let's have a look. So we go back to the sexy table. Okay, now let's see if we can find magnesium. Magnesium's even more sexy than zinc. So let's just get rid of zinc here. There's magnesium, quite high on the table. So magnesium is very attracted compared to hydrogen. So what does chlorine do? Dumps hydrogen, runs off with magnesium, and now HCl becomes MgCl. There's a new relationship. Why? Because the higher one always wins in this when it's a metal, and the lowest one when it's a non-metal always wins in the relationship. But here we have two metals competing for the same non-metal. So which metal wins? The one highest up on the sexy or the attractive scale. Okay, let's go back to then, I'm still presenting. Yeah, I'm still presenting. Let's go back to the textbook. Not there. Not there. There. Okay, let's have a look at metal displacement reactions. Okay, here on page 230. A metal like zinc solid in a solution of copper will always, one will kick out the other. Now, do you guys know the difference between zinc metal and zinc and copper like that, aqueous? This is a solid metal. This is a solution of something like copper sulfate. Why will zinc kick out the copper and form a relationship, the zinc? They haven't written the whole reaction here, so I'm going to write it down, and then maybe you guys can write it down, and let's just see what's oxidized, what's reduced here using the oxidation numbers. Okay, so let's just write that reaction down. Metal displacement. Zinc solid plus copper aqueous. Okay, let's do that. I'm going to rub this out. So say we put a piece of zinc plus, what was it? Zinc solid plus, I'm going to use copper 2 plus sulfate. I'm going to just add a sulfate because it makes the story more real. Goes to 4. Zinc sulfate. And copper solid. That's what they've more or less got. Copper solid, yeah. Let me go back to presenting. And we have the class here with us. Hi. Hello.
Hi.
Mr. Drayden, thank you very much.
Thank you.
Hi. Hi.
Hi. Hi. But everybody can help.
Thank you, ma'am.
At least Some of the let's find out. Okay, guys, find your seats, please. Oh, sorry. Okay. Mr. Thomas,
Yes.
I just want to check with you. You know that this class is still 2:30.
Is the class still 2:30?
Yes.
Okay. Did they delay it from 12:05?
Now the bound times have changed for the week.
Oh.
So today and I think Friday it will be till 2:30.
And it starts now.
It starts now. Well, it starts, yeah. The break ended now. 2:45.
2:45. Okay.
Okay. Just so that check with you. Okay, guys. Can you sit down, please?
So,
Yeah.
so I have to be there.
Sorry.
So I have to be at 2:30.
Hi. Everyone, I'm just glad to have whoever's here. So I'm going to briefly go over what we have done. We have to do what we can. No one, I wasn't aware that the times had changed. So,
Okay.
so welcome all. I hope you can hear me.
Can you hear?
Yeah. I already started at 12:15, thinking that you guys were late, but then I didn't know the times had changed. I'm glad to see so many of you still pandemic busting. I can see 1, 2, 3, 4, 5, 6, 7, at least 10 of you, I think. So well done to you all. Guys, I'm going to recap what I've taught, or I may even just teach it from scratch. The last time I saw you guys, I saw that your chemistry was a little bit weak in the department of, when I said, for example, the sulfate ion. What is the valency of the sulfate ion? And you wouldn't, I detected hesitation that you didn't know it's an SO4 2- ion. So I'm doing basic chemistry again today. Okay. This is what we call oxidation numbers I'm doing today. Just hands up. How many of you have heard of oxidation numbers? Just hands up. One hand. Anyone else heard of 2 hands? 3 hands? Okay, so you guys have heard of it, at least. Okay. So let me go over the basic rules of oxidation numbers. And this is going to be this is going to improve your chemistry a lot. Okay. Here's the rules of oxidation numbers. Now, you don't have to write them down, but try and remember them. Okay. If you start with an element like zinc on its own, its oxidation number is 0. If you end with an element like copper solid on its own, then its oxidation number is 0. Now, if something is an ion, like the Cu2+ ion, it's got an oxidation number equal to its ion, so that is +2. This is SO4 2-. So this has got an oxidation number of -2. Together they form a neutral thing of 0. Okay, look at this one. This is zinc +2. This is SO4, still 2-. So what's the oxidation number of the zinc? It's now gone to +2. The SO4 is still -2. And there are the oxidation numbers. Together, they must add up to a neutral atom of 0. Okay, so why do we bother with this? Well, we want to know which one is oxidized and which one is reduced. So we go to our mnemonic. Oxidation is the loss of electrons, or oxidation is an increase in oxidation number. OIL, sorry. So oil, your mnemonic stands for two things. Oxidation is a loss, and oxidation is an increase in oxidation number. So now you look, which of those numbers increased and which ones decreased? So zinc went from 0 to what? +2. So was zinc oxidized or reduced? It went from 0 to +2, so we say it increased. So what is an increase in oxidation number? It means, therefore, zinc oxidized. Now let's see what was reduced. Was the sulfate reduced? No, it stayed -2, -2. But look, the copper went from +2 to 0. Is that an increase or a decrease? It's a reduction. So this oxidation number reduced. So this is reduction. So do you see how it helps us to identify what is oxidized and what is reduced? Zinc was oxidized, copper was reduced. Okay. So I'm going to give you the rules. They're in your textbook on page 343, page 343. But I'm going to show you on a website. Here's the rules for oxidation numbers. Now, I'm not going to show you on a website. I'm going to show you on here. Okay. I hope you can see this. Rule number 1. The oxidation number of an element, for example, we've just done zinc alone, in its free uncombined state is 0. All of those are just elements, so they're 0. Zinc, aluminium, or all of those, even though they're diatomic, they're still 0. Rule number 2, the oxidation number of a monatomic one atom is the same as the charge. So any ions have the oxidation number equal to the charge. For example, sodium's got a charge of 1, so it's got an oxidation number +1. Sulfur has got an ion is 2-, so it's got an oxidation number of -2. The sum of all oxidation numbers in a neutral compound is 0. So for example, zinc sulfate, if you add all the numbers, it comes to 0. Okay. Rule number 4, the oxidation number of the alkali metals is 1. So group 1 is 1. Group 2 is 2, etc. And the group 7, now it says here, the oxidation number of oxygen is -2 because it's in group 6. If it formed an ion, it forms a 2- ion. Rule 6, the oxidation state of hydrogen is +1. Rule number 7, the oxidation state of the halogens is -1. It's easier to see this on the periodic table. Let me go there. So if we go to the periodic table, group 1, +1. Group 2, oxidation number of +2. Group 7 form ions that are -1, so they have an oxidation number of -1. These ones, oxygen and sulfur, selenium, whatever Te is, polonium, I guess, all of those have got an oxidation number of -2 because they're in group 6. So then these guys in the middle here are a little bit ambivalent. They can be +3, ignore all these transition elements. They can be +3 or -2, 3, 4, 5, -5. This can be +4 or -4. These can be -3 or +6. So there'd be 2, 3, 4, 5. Sorry, +5. So these guys can be either plus or minus. But this is how you work it out. +1, +2, could be +3, could be +4, could be +5, or it could be -1, -2, -3, -4, -5. We'll be able to work it out from the rules. And there are the rules. Anything by itself is is 0. Okay, just one last thing. Today, not for any other reason, but I'm just going through basic chemistry, and I'm working from the grade 10 textbook on page 230. So let's have a look here at different types of reactions. For example, halogen displacement. What happens if you've got chlorine gas bubbled through a solution that contains the bromine ion? Will it form the chlorine ion and bromine liquid? So this is an example of halogen displacement. We did hydrogen displacement when you weren't here. We did metal displacement. I've just done it now on the board. And now we get halogen displacement. Okay, so one halogen will displace another halogen. Now, as I was explaining before you arrived, and I'm sorry to make the sound, will chlorine boot out bromine? And let's see why it will, if it will. So we go to our BFF. Let's see where on the sexy scale chlorine and bromine occur. Okay, so there's chlorine. Let's see if we can find bromine. Okay, I just want to get rid of this one and that one. Okay, on the sexy gal scale, here's bromine. I saw it here. Now, who's sexier, chlorine or bromine? The lowest one is the sexiest, most reactive nonmetal. So chlorine and bromine, if there's a competition for, say, hydrogen or some other guy, HCl, let's say, and you add bromine or chlorine to a bromine solution, the chlorine gas is going to boot out the bromine, and chlorine is going to date whoever was left. So that is why this one can displace that one. Anything lower down will displace something higher up on the table. So going back to here, do you see why chlorine will react with a solution of bromine ions and it'll form chlorine ions, and bromine will be single again? Okay. What about chlorine and iodine? Is chlorine sexier than iodine? Can chlorine boot out iodine? Well, I'm guessing so. Let's go to the table. There's chlorine. Let's get rid of this bromine. Where is iodine? Oh, look at that. Iodine's quite high up. Iodine's very average. So if chlorine comes along, chlorine gas, it'll boot out the dating relationship of the iodine ion with something else, and it will displace it, and it will take its place in the relationship. So let's have a look at one more example. What happens if bromine comes along and iodine is in the solution? I'm just going to write that one out on the board, and then, so that's bromine liquid plus 2 iodine aqueous goes to form bromine and iodine. Okay, look, I just want to write that out on the board. Maybe you guys can also write it down. Okay, just write it down. Bromine liquid plus, let's just say we've got a solution of 2I minus. What would iodine be linked to? It doesn't really matter, but goes to form 2 bromine minus plus iodine solid. Let's just put here zinc iodide. Goes to form ZnBr2. They haven't included something here. This is an incomplete reaction. So let's just complete it for you. Okay, so I'm going to stop presenting and go back to here. Let's just stop presenting. Okay, I've tried to give a slightly more complete type of reaction. You've got bromine liquid added to a solution of, let's say, zinc iodide. Would go to form zinc bromide and iodine solid. You guys happy with that? So let's apply oxidation numbers. Let's try and find out which is oxidized, which is removed. Does anybody feel like bringing their desk to the front? Because it's actually much better if we do this interactively. Matthew did such a fantastic job last time. Anybody prepared to just bring your desk to the front? Yay! Who was that? Is it Mustafa, maybe?
Yes.
Okay, fantastic. Thank you, Mustafa. Greatly appreciate it. Okay, fantastic. Now, guys, according to those rules, any element by itself has an oxidation number of what?
Zero. Let's say 0.
Well done. It's neutral because it's all by itself. Do you see something else here that could be 0?
The iodine. That's what.
Thank you, the iodine. Okay, so bromine starts at 0. Now let's have a look. Iodine is in group 7, so it's going to have an oxidation number of, what's its ionic state? Minus. Iodine, group 7, forms ions that are minus.
-1. That's
Well done. And there's 2 of them, so what is the zinc to balance it out going to be?
Ultra is +2.
Well done, you fantastic. So zinc starts out at +2, iodine starts out at -1. Now zinc here, bromine's also in group 7. So what is bromine's number going to be on this side?
-1.
-1. Well done. And there's 2 of them. So to balance it, zinc is still going to be +2 ion, right? So this is going to be +2. 2. Fantastic. So now we look at the bromine went from 0 to -1. The zinc didn't change. The iodine went from -1 to 0. Oxidation is an increase in oxidation number. So which of those was oxidized?
Bromine.
So your bank balance went from 0 to -1. Is that an increase? Or if your bank balance went from -1 to 0, is that an increase?
Zero, not really.
So this number went from -1 to 0. So isn't that an increase?
Yes.
Okay, so your iodine is oxidized. And your bromine's number is reduced. Bromine is reduced. So now do you see what's oxidized and what's reduced? By just looking at their oxidation numbers. The zinc is a spectator ion. It just stayed at +2, +2. The zinc was neither oxidized nor reduced. It's a spectator ion. But I needed to include it because zinc is like a guy. Zinc and iodine are dating. Along comes bromine. Okay, now let's have a look on the scale of sexiness where bromine sits. Okay, if you've got a table in front of you, it will help. But let's have a look. Is bromine sexier than iodine? Okay, look, on that scale, I hope you can see it. Here's bromine. There's iodine. Do you see that bromine is hotter? Bromine is hotter than iodine because it's lower down. So what happens? Iodine is dating zinc. He's a spectator. He's got, along comes the more attractive bromine that's lower down. Bromine runs off with zinc. Iodine is left in an solid state. I2 solid state. Does that make sense? Does that chemistry make sense?
That makes sense.
Fantastic. Okay, so now you're beginning to, I hope, get a clear idea of how chemistry works. Let's go. I just want to present. Oh, I'm still presenting. Okay. I just want to go to the next page of the textbook. So the textbook, what page were we on? 230. Let's go to page 231. This is the grade 10 textbook. Okay, here's a precipitation reaction. Silver nitrate combines with sodium bromide. Fill a test tube to 1/3 of its volume with sodium bromide. Add silver nitrate solution to the test tube. Observe what will happen. Okay. Any ideas what will happen? So if you don't mind, just write this reaction down. NaBr plus AgNO3. So that is AgNO3 plus NaBr. Right. Anyone know what the oxidation numbers of all these things are going to be? What's the oxidation number of the nitrate ion? And this is why I'm doing it, because I know that you guys don't know your ions very well. This is what inspired me to do this. What is the charge on NO3?
Nobody knows.
Okay, but you've heard of the nitrate ion, right?
Yeah.
Okay, it's -1. The nitrate ion is -1. So it's what's its oxidation number going to be? For the nitrate ion?
-1.
-1, well done. Therefore, to balance it, what is silver's oxidation number?
They say +2.
But there's only one of these ions. With one of them.
It's 1.
So it's going to be +1, right? And then they're going to go, and what is this sodium here? It's in group 1. What's its oxidation number? +1, and bromine's in group 7, so it's going to be?
-1.
Lovely. Now they're going to swap partners, okay? So can you guys write them as if they've swapped partners? So this guy's going to go out with that girl. This girl's going to go out with that guy. So it's just swap their partners around. Okay, so they've swapped partners. So what's the oxidation number now of the silver and the bromine? Let's start with bromine. What's bromine's oxidation number?
-1.
Lovely. So what is the silver?
+1.
+1. What is the sodium?
+1.
+1. And nitrate?
-1.
-1. So all they've done is swap partners. Which was oxidized, which was reduced?
Nobody knows.
Someone said none. Who said none?
Azra said none.
Who said?
Azra.
Okay, well done. Nothing was oxidized, nothing was reduced, because no numbers changed. So this is an example of a non-redox reaction. But people are supposed to learn, and I was just telling those who were here before that in 1970, when I was in matric, and all the way up to 2013, when CAP started, chemistry was about learning reactions. Hey, who's laughing at me?
It's just Azra. It's just Azra.
You're laughing at the fact that we were doing chemistry back in...
She's laughing because she's old.
Yeah, I know.
That's it.
But like a good wine, we just keep on getting better. Okay, so this is a non-redox reaction. And what we learned was that when silver reacts with a halogen, it forms a solid. Why? Because silver bromide is insoluble. It used to be the test for halogens. You add silver to a solution with halogens and it precipitates out. Have you guys heard of precipitation reactions? Where you add two solutions and something precipitates out? Heard of it?
Yes.
Okay, won't you write underneath here that the silver bromide precipitates? Silver bromide forms a solid, precipitates out. You see, they may ask that in your final paper, and it's good to know. And that used to be the test for halogens, is to add silver to it, and then if it precipitates out, then you know that there was a halogen in the solution. Okay, but it's a non-redox reaction. Let's have a look again. Let's go back to the grade 10 textbook as another example of reactions. So we're on study and master page 231. Okay, gas-forming reactions. Sodium carbonate plus HCl. Add a spoonful of sodium carbonate to a test tube. Pour dilute hydrochloric acid into the test tube. Observe what happens. Okay, you guys who were laughing at me, what does an acid plus a carbonate form? Three things. We learned this back in the 70s very well. Do you guys in the 2020s know what happens when you add an acid to a carbonate? Let's see. Okay, won't you write that reaction down? HCl plus sodium carbonate. Okay. So like I say, we spent very little time memorizing this. This is why we always did so badly in chemistry. People did shockingly badly up till caps in chemistry. They got like half the mark they got in physics because they were asked to remember an acid plus a carbonate forms a hum and a hum and a hum. What are the three hums that it forms? Lovely. Salt plus water plus
Carbon dioxide.
Any teacher would do their nut to have such geniuses. Okay, work out which salt and well, you know, water, H2O. Okay, so let's write the salt and the water. So H2O, but what is the salt? Well done. Whoever said sodium chloride?
Untreated was sodium chloride.
Okay, work out the oxidation numbers of all of these. Okay, what's the oxidation number of hydrogen? Plus 1. And chlorine? And sodium?
Plus 1.
Lovely, and there's 2 of them, so what is carbonate?
Minus 2.
Minus 2, lovely. What is sodium?
Plus 1.
Still plus 1. Chlorine hasn't changed its group.
Minus 1.
Hydrogen in water is?
Plus all of a sudden lost. So.
Plus 1. Oxygen is?
Minus 2.
Minus 2. Lovely, because there's 2 of those. Okay, what is oxygen here?
Minus 2.
Yeah, oxygen is always minus 2. And therefore carbon must be?
What's it? As I said, plus 2. They're saying 4, so minus 4.
Okay, but look, we got 2 times minus 2 is minus 4.
They're saying plus 4.
Plus 4, correct. Okay. So this is another example of a common reaction. Is it redox though?
As I said, yes.
What has increased its oxidation number?
So they say they can't see.
Which has increased its oxidation number?
So now they definitely can't see.
Has anything changed?
Yes. Yes.
Okay, well, I'm waiting for you to tell me what has changed its number. Look, sodiums,
They all say hydrogen.
but the hydrogen's plus 1, it's always plus 1. The O is minus 2. Has okay, let's work out the numbers for CO3. What would CO3 be? What is the oxygen here?
Minus 2.
Minus 2. And there's 3 of them. So that makes minus 6. Which is cancelled out by 2 sodiums, which is plus 2. So what is the carbon here? This is 3 times minus 2 is minus 6. Plus 2. So what is the carbon?
That's 4.
I heard someone say it. Plus 4.
Plus 4, so.
Okay. So carbon hasn't changed either. Nothing has changed. The carbon was +4. It's still +4. The sodium hasn't changed. The oxygen hasn't changed. This is an example of a non-redox reaction. Okay. But it's worth remembering because I think in your exam, they're going to give you an acid plus a carbonate. It's quite possible. And if you don't know that an acid plus a carbonate forms salt and water and carbon dioxide, how are you going to do it? Okay, let's go to another reaction. Here's an easy one. You did it last time. Sodium hydroxide plus HCl forms, what is an acid and a base form?
Salt and water.
Lovely. And you know, I can just by looking at it, I can tell you that it's going to be a non-redox reaction. That looks too easy. Shall we just skip that one? Okay. But why don't you, just for the practice, just write down the salt and the water. Won't you just do sodium hydroxide plus HCl and write down the salt and water, which salt is formed? They're just going to swap partners again.
Yeah.
Okay, so sodium hydroxide plus HCl, and you know, well done, salt and water. Now here they actually say this is a redox reaction. Take sodium, put it in water, and see what happens. Do you guys remember what happens when you drop a piece of sodium metal onto water?
Yes.
What happens? Ask them, Mustafa.
What happened? Matthew says it burns. I think he's wrong.
What happens?
Matthew says it burns.
Yeah, well done. It floats on the top, it fizzes around, it sometimes burns. Okay, won't you just do that reaction? Let's do it. So that's sodium plus water. Okay, so sodium plus water, what is formed?
Iodine said salt and water.
Salt and water. But you said it burnt. Now salt and water is not going to burn. You need something that's going to burn.
I don't think anybody knows the answer, sir.
Well, do you think sodium is sexier than hydrogen? Should we go and have a look? Okay, so let's just go and have a look. So we go to the sexy table. Let's find sodium and hydrogen. Okay, hydrogen always sits at naught. There's hydrogen. Where's sodium? There's sodium. And they both competing for oxygen, which is somewhere there. One of these is oxygen. Anyway, oxygen's a girl somewhere down here. There's lots of oxygens, but I'm not sure which one. Of the two, which one is going to get the girl? The sodium or the hydrogen? These are the two guys in question. Who's sexier?
Sodium.
Yeah, because it's higher up. So sodium is going to kick out the hydrogens and date oxygen. Okay? That's what's going to happen. So what do you think the gas is going to be that's formed? What's the gas that's going to form? Any guesses, Mustafa?
I think they guesses,
So what is going to be given off? If this now dates the oxygen, we're going to get sodium plus oxygen. What do you know that sounds like sodium and oxygen? And they said add an indicator. They said add bromothiamyl blue to it. So what do you what's the missing piece here?
the oxide, sir.
What must I add to the sodium?
So they're saying the oxide, sir.
Are they saying hydroxide?
Yes, yes.
Okay, I hope they were. Plus hydrogen gas. Okay, so let's balance it. Obviously, we've got something wrong with our hydrogens. There's 3, so let's put a 2 in front here. Let's put a 2 in front there. Let's put a 2 there, and then I think it balances. Okay, so there's the reaction. Now, how about adding the oxidation numbers to all of those? And let's see what's oxidized and what's reduced. Okay, who can tell me what something on its own is going to be? What is going to be on its own?
0.
Lovely. What's the hydrogens always?
1.
The oxygens always?
-2.
Lovely. This sodium is with something. So now what is it going to be? It's not on its own.
1.
Lovely. It's in group 1. What's that hydrogen always?
1. That's what I was
1. And what's the oxygen? -2. And what's this gas here by itself? What's its number?
0.
Well done. Sure. Okay, now tell me what's oxidized, what's reduced. Which one has increased its number? Which of these has increased its number?
Sodium.
Well done. So is that increase oxidation or reduction?
Oxidation.
Oxidation. Lovely. So sodium oxidized. So what's reduced? Hydrogen is reduced. There we go. And please remember this reaction for metric 2 and for grade 10 and for grade 11. When you add any element from group 1 to water, hydrogen gas is booted off and a base is formed. And that is why we call it the alkali metals. Alkali. Because the group 1 metals form sodium hydroxide. That's an alkali. So this is why sodium, lithium, potassium, rubidium are all the group 1 elements are called alkali metals because they form an alkali. Okay. I can see you guys are getting very good at this. Let's see if you can do grade 10 work. Let's go back. Okay, let's have a look at the next bit of grade 10 work. So here are some redox reactions. Copper sulfate plus zinc. And then I want you to just tell me what happens here with experiment 5 when you add copper sulfate and zinc together. Okay, so write the balanced reaction, see what's oxidized, what's reduced, and tell us what you see happening. Okay, so that's CuSO4 plus zinc. Okay, Mustafa, I know this is grade 10 work and I'm probably boring you. Who could tell us what they think is going to happen here?
The what? But you said the zinc and copper is gonna swap places.
Well done. Totally correct. And what are you going to see form? And what are you going to see happen? So let's swap places. We're going to have zinc sulfate. And we're going to be left with copper metal. Okay, so you're going to see your zinc. Do you guys know what zinc looks like? It looks like a roof. Okay, it's like a shiny metal. You chuck that into, who knows what color copper sulfate is?
Nobody.
It's a blue solution.
Oh.
So you chuck this shiny metal into a blue solution. And anyone know what color your water pipes are? That's going to form copper. What color are your water pipes?
Nobody looks at the water pipes, so.
You probably got plastic water pipes anyway. No, it's a kind of a greeny brown. Okay. So you're going to get a greeny brown and then you're going to get zinc sulfate formed. Okay, just see what is oxidized, what is reduced by putting in the numbers here. So what is the sulfate ions number? Who knows what this is going to add up to?
Matthew said it's -2.
Matthew's 100% correct. So what is this copper going to be equal to?
+2.
Plus 2. And then what is this zinc going to be?
Zero.
0, because it's all by itself, right?
Yeah.
And then what's this zinc going to be? SO4 hasn't changed. It's,
We don't know. We don't know.
you do know?
We do.
Ask Matthew. Matthew, what's this going to be? There we go. So this zinc is going to become? There we go. And what's this going to be?
Zero.
0. Well done. Okay, so what is oxidized and what is reduced? Which of those is oxidized?
Let's say zinc is oxidized.
And what is reduced?
Copper.
Okay, now here's the question for you. Of the two, which is the sexier, zinc or copper?
I haven't checked them out.
Look, here's SO4. She's dating copper. Along comes zinc. If zinc is less sexy, does anything happen?
No.
No, so zinc must be sexier, right?
Yeah.
Therefore, zinc must be higher or lower on that table than copper.
Higher.
Higher. Let's just check and see if that's true. Okay, so let's go and have a look at where zinc and copper are. Okay, so going down here, down, there's zinc. Zinc is high. Let's see if we can find copper. We have to keep going. I don't see any. There's one copper. There's another copper. And I know somewhere down here, there's another copper there. So copper is definitely less sexy. Copper, there's your 3 coppers. So zinc is going to kick out any one of those valencies of copper. And that's why the reaction occurs. It's all chemistry. The sexier guy gets the sulfate gill. Okay, let's go back to grade 10. Guys, could I ask you to copy down and do the same for all of those? Identify which is oxidized, which is reduced, write their oxidation numbers. Tell me which one's well, I don't think you actually have to say which is the sexier, but just, won't you write down which was oxidized, which is reduced? And some of them are maybe not going to be redox, but if you could just work out which ones are redox and then just find which is oxidized, which is reduced. Thanks. So just copy each of those down and do it.
Brownie. Bracket gas. Is equal to 2 sodium aqueous plus bromine. Yes. Sodium hydroxide. Plus sulfuric acid. The fuck? That was Russian.
Okay, Mustafa, I'm going to give you almost godlike power in a moment. You're going to call on various people and they're going to tell you what's oxidized and what's reduced. You're going to pick on people. So,
They're so busy, so.
I know. But just let them know that you're going to be the grand meister of who's going to have to tell the answers.
I get to choose.
You must just look at it. Just look at it.
I just got back. That's not come back. Pretty yummy.
Are most people finished, Mustafa?
They're almost.
Okay, you tell me when they are.
A couple of hours. Oxidation numbers 26 here. I think.
No, you couldn't go to that.
Oh, please. Oh, that's it.
Oh, I need to turn off that mic, my bro.
Hmm?
Turn off that mic. What's wrong with you, Anis? Trying to hear. I can hear you coughing, my bro. Now what? This is no. Straightforward.
Are we ready to go?
2 more minutes, sir.
Okay, 2 more minutes. Okay, what you also have to do is you have to classify the reaction. Is it redox? Is it a hydrogen displacement? Is it a metal displacement? Is it a halogen displacement? Is it a precipitation reaction? Is it a gas forming reaction? Is it an acid-base reaction? Is it, yeah, that's it. So does it displace hydrogen? Does it displace a metal? Does it displace a halogen? Is it a precipitation reaction? Is it a gas forming reaction? Is it an acid-base reaction? Or is it just a redox reaction? Or not? So try and classify it as well.
Oh, I don't know the answers. Okay.
Great. Okay, Mustafa, pick on someone. Anyone.
Alicia.
Alicia.
Yes. What?
Okay, ask Alicia what is oxidized here.
What is oxidized in the first one, Alicia? What's Alicia's reading? Alicia says it's bromine, I think.
Tell Alicia she's a genius. Okay, ask Alicia what is reduced.
What is reduced, Alicia?
The shoulders. The shoulders. The shoulders.
Chlorine.
Tell her she's a double genius.
Double genius.
No, she wants to be a triple genius. What is displaced in this reaction? Is it hydrogen, metal, or a halogen?
Halogen.
She's a triple genius. Well done. Okay, fantastic. Woo! Okay, pick on someone for the second reaction. You can even choose Matsadiso if you have to, because she's also online. But she's also here. But who you going to choose?
I choose Aiden.
Okay, Aiden. Aiden,
I choose Aiden.
what is oxidized or reduced?
What is oxidized? What oxidized Aiden? That's what I want. I'm not asking
We're waiting, Aiden.
His time is sir.
You rude.
That's a drug. What oxidized? I'm thinking of
So, Aiden, what's oxidized? What's reduced?
He's checking, sir.
I can smell the rubber.
He doesn't know, sir.
Okay, who wants to give the answer? What is oxidized? What's reduced? Okay, let's have a quick look. Look. That's going to be 1. That's going to be -1. That's going to be 1. That's going to be together -2. That's going to be 1. That's going to be -2. That's going to be 1. And that's going to be -2.
Oh,
There we go. Nothing is reduced. Okay, Aiden, what type of reaction is this? It's a...
you said it's an acid base.
It's an acid-base neutralization reaction. Just write that down. Well done. Okay, pick on the third person.
Dina.
Zena.
Alicia answered.
Okay, Zena, what's oxidized and reduced here? Look at them. +1, -1, +1, +1, -2, plus 1 minus 1 plus 1 minus 2 plus 4 minus 2. Is anything oxidized and reduced there?
It looks like it. Yes, that's what they say.
What is oxidized?
What after that? After I said it's a really good question.
Is this a redox reaction?
Yes, that's what they say. They say yes.
Okay, then something must increase and decrease its numbers if it's a redox reaction. What is increasing it and decreasing its number? Okay, let's just go a bit deeper. In the CO3, you got 1 plus 1, that's the hydrogen. Ask Zena, what are each of the oxygens?
They say carbon, sir.
What is each oxygen here?
So they said it's carbon that's oxidized.
Okay, but let's just work out the oxygens first. Oxygen's always minus 2, right? So there's 3 of them. So that's 3 times 2 is 6. Plus 1, plus 1. Those add up to plus 2. So the carbon must be plus 4. And there it's plus 4. So the carbon's still plus 4. Can you see why that is? There's your 6, plus 4, plus 5, plus 6. There's your minus 6 plus 6. So carbon was plus 4, carbon still plus 4. So ask Zena, is anything oxidized?
She says no.
That's it. It's a non-redox. So what type of reaction when an acid plus a carbonate forms 3 things?
Salt, water, and carbon dioxide.
There we go. It's an acid plus a carbonate. It's a gas-releasing reaction. So it says a gas-forming reaction. This would be a gas-forming reaction. Okay, the next one, barium nitrate plus sodium sulfate forms barium sulfate and sodium nitrate. Choose someone to do the next one. Ask them who's doing it next.
Azra, what is oxidized?
Who?
So
Ezra.
Azra,
Okay. Ask Ezra what is reduced and oxidized in this one. Barium 1.
I'm going to give a random answer to the answer.
Okay, let's start with Ezra. What is the charge or number, oxidation of a nitrate ion? What's this nitrate ion's number?
-1.
Lovely. So there's 2 of them. So what's the barium?
+2.
Lovely, +2. Okay, let's go to here. What is the sodium?
+1.
+1, and there's 2 of them. So what is the sulfate?
-2.
-2. Does the barium change here? It's still with the sulfate, which is -2. So what is the barium here?
+2.
+2. And then what's the sodium here?
1.
+1. And the nitrate?
-2. Apparently. 1 -1.
There we go. So has anything changed, Ezra?
She says no.
Okay, great. So it's not a redox reaction. So let's have a look at it. It's got barium nitrate and sodium sulfate it says here, I just want to see this. What is the symbol after each of those? It's so the one is these are both aqueous and they go to form a solid here. That's aqueous and aqueous goes to form a solid. There's a solid. So what is this type of reaction when it forms a solid?
As I said, it's a solid.
I didn't.
Ezra, what is a solid forming reaction called?
I didn't say that.
It begins with a P.
Is it phosphorus?
It's a precipitate. Precipitate. Okay, so this is a precipitating reaction. Here's your solid. Okay, choose someone next, Mustafa.
I actually feel like Pascal.
Okay, who do we have next?
Pascal, sir.
Mustafa.
Pascal, sir.
Sorry, who?
Pascal.
Pascal. Okay, great. Pascal, so you got magnesium, goes to form magnesium chloride, which is oxidized, which is reduced.
So the magnesium is oxidized.
Tell him he's a genius.
The genius.
Okay, let's see if he's a double genius. What is reduced?
The hydrogen.
Just look again. Hydrogen. Where does the hydrogen go? Hang on. Oh, this should be hydrogen gas. Okay, you're right. You're a double genius. Well done. Okay, so hydrogen is reduced. And then what type of reaction is this? What is forming? So you go from solid plus aqueous goes to form aqueous and a gas. So what type of reaction would this be? If you had to classify it, I guess you would call it out?
Gas forming reaction.
Well done. Fantastic. Okay. Woohoo. Guys, could I ask you now to finish off in your paper 2 booklet all the questions on acids? Okay. The questions on acids. Mustafa, thank you so much. That was a great job.
Welcome, sir. I'll do it again.
So done.
Okay, super. Thank you so much, Mr. Drayton.
See you, and yeah, the belt. So Friday, I think it will be the same time. It'll also be much longer, but you'll be the second session, I guess.
Sorry, just say that again.
I said Friday, it will also be